Hello and welcome to the NPTEL MOOCs course on Foundation for Virtual and Augmented Reality Systems. Today we are going to cover the remaining part of the implementation discussion that we are continuing. So, we will also continue the implementation discussion today, and after today's part the discussion will come to an end. So, in order to understand this discussion, let us quickly recap the interactive system development life cycle. So, the life cycle is shown here. Now, we start with the feasibility study, then we have requirement gathering, analysis and specification, then we have the design, prototype, evaluate cycle, followed by code design, coding and implementation, code testing, followed by empirical study, followed by deployment and maintenance. Now, out of these stages, we primarily talked about requirement gathering stage, design, prototype, evaluate stage and empirical study stage. So, in the design, prototype, evaluate cycle, there are three stages: design, prototyping and quick evaluation of the prototype. So, we have covered these. Other things we did not cover because these are standard, whereas the ones that we covered had some difference with other software development. So, we covered those in some details. Now, the issue is what is required. So, before we move to the issue, let us quickly recap in each stage what happens. So, in the requirement gathering stage, we gather requirements for functional and non-functional, that is usability requirements. We may need to conduct different methods, carry out different methods or approaches to collect the requirements, such as contextual inquiry, which we have discussed in details. Now, here two things are there. One is collection of requirement from end users and also clients. Now, sometimes they are same, sometimes they are different, most of the times they are different. So, based on the requirements, we have to decide on functional and non-functional requirements. Usability requirements primarily come from end users. Some other non-functional requirements may come from clients, and functional requirements also may come from both client and end users. Now, in order to identify all the requirements, all different types of requirements, it takes long time. It may span months to collect all the possible requirements or all the requirements that are generally expected by both the end users as well as the clients. Then we go to the, once the requirements are gathered, we go to the interface design part, which comprises of design, prototype and evaluate cycle. Now, here in order to come up with a design, we may rely on intuition, or what we can do is start with design guidelines, followed by brainstorming within the team to come up with a design, suitable design. This is followed by prototype building, followed by quick evaluation using methods such as cognitive walkthrough or heuristic evaluation, and this goes on in cycle. Many times we may need to carry out the cycle, so that eventually we come up with a stable interface design, meaning that further evaluation is not likely to throw up many new issues. How long this stage can take? It can also take months. Although each cycle execution may take less time, 1 or 2 days, but since we have to carry it out multiple times and it is not possible to fully devote time only for this purpose, there may be other activities. So, considering those, it may take between couple of weeks to a month time. Then comes the coding part. So, it starts with first the code design, that requires again coming up with the design, brainstorming like interface design. Here the design language is DFD, ER or object oriented approaches, UML and so on. Coming up with the proper design through several iterations and brainstorming again is time consuming. It may also take months or at least few weeks, couple of weeks. This is followed by implementation, coding, testing. Implementation involves coding and code testing. So, you need to first code, then test it, primary level, secondary level. Primary level may be review based, secondary level may be more systematic structured way such as black box or white box testing. That can be done at the unit levels, then they are integrated, then system level testing and so on. So, this testing also is monotonous and time consuming, may take weeks. The last one is usability testing. That is with code testing we know that the system is executable, but we still do not know whether the system is usable. We expect the system to be usable because we have followed design, prototype, evaluate cycle. However, whether that is true or there is still some gaps, that we need to estimate through usability testing or empirical study. Now, in empirical study we need to identify participants, we need to set up, we need to get participants time. It may also take weeks. So, all these taken together takes long time. One problem with the traditional approach that we have discussed so far is the rigidity. That is, every stage has to be completed before the next stage starts. So, this may lead to time and cost overrun and even non-acceptance by customer, that is the client, who may say that so much escalation in cost and time is not acceptable. Now, why that is problematic, this rigidity? Because it has a strict requirement at each stage. So, for example, requirement gathering stage, all requirements have to be identified first. Similarly, coding stage, all units have to be coded before it is sent to testing phase. So, this type of outlook view that every stage has to be completed creates the problem. So, what it says, the traditional way of doing things says is that we need to implement or we need to carry out or we need to execute all activities, requirements at a stage before we can go to the next stage and before deployment. So, when we talk of deployment stage, that means everything is perfectly done, all requirements identified, coding done, code tested, usability tested, then only we go for deployment. Now, since each stage can take long time, so eventual deployment may take very long time. Also, another requirement is why each stage requires a long time. One is execution of the stage, other one is the need to keep documentation for each stage. So, there are lots of documentations required in each stage. What are the documents? Say for example, feasibility study stage requires one, then requirement gathering stage requires SRS, detailed SRS or software requirement specification documentation, then design phase requires design doc. Now, this is about code interface design. Code design also requires documentation. so that it is easier to understand and debug by other teams. Testing documentation, code testing primarily. Then usability study report. So, lot of documents needed to be prepared if we follow the standard approach, the standard interactive system development life cycle. So, already we have listed such documents that are required. Just to recap, we need feasibility study report, SRS for requirement gathering, analysis and specification stage. SRS stands for software specification, software requirement specification or system requirement specification. Then we need design documents both for interface and interaction as well as code. Then we have testing document for code. We also need usability study report. Broadly, these 5 required before we go for deployment. This is clearly problematic. It may lead to time and cost overrun. So, in order to overcome this situation, we need to adopt a method that can deliver quickly. So, there comes the agile development framework or agile development approach. The idea is that agile or fast development should be encouraged, should be implemented in practice. And if we implement this development practice, then it ensures quick turnaround of projects which are more acceptable to the clients. So, it eliminates unnecessary things and documentations. It starts small. That means, when this approach is adopted, we do not try to do everything from the very beginning. Not all requirements will be collected, not the entire system will be developed and tested, and so on. So, what is this process flow? More or less similar to the standard system, shown in a different way, that is conceptualization, then inception, which involves creation of the team, arrange funds, resource, etc. Then iteration, also known as sprint, which is the development cycle, followed by release, includes testing, training, documentation, etc., followed by production, that is the ongoing support, followed by retirement, that is end of life activities. So, production roughly refers to deployment and maintenance. Release and production release refers to deployment, production refers to maintenance, retirement is retirement. So, conceptualization and inception roughly refers to both the feasibility study as well as requirement gathering. Iteration or sprint includes all the other stages, as we have seen in the interactive system development life cycle. Now, this iteration or sprints typically requires 4 to 6 weeks each sprint, as compared to the whole ISLDC, interactive system development life cycle, ISDLC, which may take months, 6 to 9 months, whereas each iteration or sprint for development in the agile approach may take 4 to 6 weeks, and that is quite expected because we are not trying to do everything. So, this sprint includes requirements, development, testing and delivery. So, requirements based on product sprint backlog, customer stakeholder feedback, then followed by development, then testing including training and documentation, followed by delivery to production. 4 to 6 weeks, which is quite acceptable and manageable. So, how to make it work? How to be able to deliver within 4 to 6 weeks? It requires daily meeting or brainstorming of the development team, live demo after each iteration, that the iteration what the outcome of the iteration is, feedback, quick feedback, regularly collect from stakeholders, customers and share with team before next sprint, so that next time it can be addressed. Idea is to remain agile, that is to be open to make changes based on feedback as quickly as possible. So, that is the overall idea, overall philosophy, that we try to make things produced faster, even if that means that not everything is implemented, only some of the identified requirements are implemented. And as we keep on delivering, we keep on adding features. Unlike the standard ISDLC method, where we first complete the system and then deliver. So, there are many popular agile methods or frameworks available, such as Scrum, Extreme Programming, DAD, Disciplined Agile Delivery, DSDM, Dynamic System Development Method and so on. So, agile method provides a better way to develop acceptable products, whereas ISLDC is primarily meant for understanding the overall flow rather than actually building practical systems within a reasonable time frame. So, it is primarily for pedagogical purpose, whereas for practical purpose agile frameworks are more suitable. To read more on this agile framework, you can refer to the Agile Manifesto available online, and Agile Development Principles again available online. You can refer to these for further studies. So, with that we have come to the conclusion of this lecture. So, what we have learned? We have talked about the prototype evaluate part of the design prototype evaluate cycle, how to build and evaluate prototypes. Then we talked about empirical evaluation, how to finally evaluate usability, and also discussed the empirical evaluation using the case study of Majuli. And finally, we talked about the agile development method, that is the more practical way of building interactive systems as compared to the standard system development life cycles. So, this completes our discussion on system implementation part. Earlier we talked about design. First we talked about requirement gathering, then design, followed by implementation. So, all three aspects of building a system is now complete. In the next few lectures, we will learn different aspects of the virtual and augmented reality systems. Primarily, we will devote our attention on understanding an important topic, that is optimization. How do we optimize the experience as well as the system requirements? So, user experience optimization to manage psychophysiological constraints, we will talk about these. Also, we will talk about adopting optimization approaches for resource or system optimization. So, for further studies on some of these concepts that we talked about here, such as prototype building, prototype evaluation, empirical study, as well as agile method, You can refer to this book, Human Computer Interaction, User Centric Computing for Design. Also you can refer to the NPTEL course on the design and implementation of human computer interfaces, specifically weeks 4, 5, 10 to 12 for different discussions on the different topics covered in this lecture. So, with that we come to the end of this lecture. I hope you could follow the topics, you could understand the concepts, and you are in a position to apply the learning to practical scenarios. Looking forward to meet you all in the next lecture. Till then, thank you, goodbye and happy learning.